I am Mr. Ehemari Andrew from Daily College. We are about to take a topic in physics called heat transfer. Heat is a concept of energy, and everywhere we see heat, at home, by your stove, by your cooker, you feel heat when you light up the stove. So now we want to talk about how this heat is transferred. First of all, when a body transfers heat, the amount of heat transferred depends on some certain factors. So we have factors by which heat is transferred are mass of the body, specific heat capacity of the body C, heat capacity of the body capital C, and temperature change delta theta. Now we can sum up these factors together mathematically. Does heat absorbed by a body, which is H, is equal to mass times specific heat capacity times temperature change. Temperature change. That is quantity of heat absorbed capital H is equal to m small c delta theta. M is equal to mass of the body C is called specific heat capacity delta theta is equal to change in temperature. Then H, the quantity of heat. So what this formula is telling us, H equal to mass times C times delta theta, simply means that the quantity of heat H that a body can absorb depends on the mass of the body, the nature of the body, and the amount of temperature present. Let's give example. If I have a big pot and a small pot, and I put them upon a particular heat source like stove, and I'm waiting for the water to start boiling, probably there's water in the pot, you find out that the one in the small pot will boil faster than the one in the big pot. Why? Because the mass of the big pot need to absorb more heat before the water can start boiling. That's what this formula is telling us. Now I want to quickly look at the definition of all these factors mentioned. Like for example, the mass of a body, we all know that. Now I want to talk about the specific heat capacity that is there, and the heat capacity also. You can see we are talking about heat capacity and specific heat capacity. Specific capacity and heat capacity. So there are difference between the two. We want to get it clear. So let's look at the meaning of heat capacity and specific capacity. Normally write it capital C, when the other one will write it small c. This is the quantity of heat required to raise the temperature of a substance by 1 Kelvin. So this one talked about the whole body. That was a quantity of heat required to raise the temperature of a substance. We are talking about the whole body, the whole pot. But there's difference between this and the second one, which is specific heat capacity. Which we denote as small c. So we define this as the quantity of heat required to raise the temperature of a substance, okay, of 1 kg of a substance, of 1 kg or 1 kilogram of a substance by 1 Kelvin. So the difference is that heat capacity deals with the whole mass, while specific capacity deals with 1 unit mass. 1 unit mass simply do 1 kg. So there's a relationship between the two of them. Relationship between heat capacity and specific heat capacity. Thus, capital C is equal to m small c. This means that heat capacity is equal to mass of a body, times specific heat capacity. So that's the relationship between them. So this is the heat capacity, mass of the body, specific capacity. We normally use capital letter C to represent heat capacity, while we use the small letter c to represent specific heat capacity. Of course, the m there is called the mass of the body. We'll just take one equation. Let's solve one problem here. Example 1. Calculate the quantity of heat absorbed by a body of mass body of mass 50 kg whose specific heat capacity is 140 joule per kilogram, and the rise in temperature being 30 degrees Celsius. Calculate the quantity of heat absorbed by a body of mass 50 kg whose specific heat capacity is 140 joule per kilogram and the rising temperature be 30 degrees Celsius. Of course, what we are going to do, what I'm calculating quantity of heat. And from our formula, we find that H represents quantity of heat. H represents quantity of heat, M represents mass, C represents specific heat capacity, while delta theta represents rise in temperature. So therefore, before we start the calculation, we must write out the parameters. We are looking for H. H, we should carry question mark. Then they gave us M, which is mass, equal to 50 kg. Also, we are given the change in temperature with delta theta. Delta theta is equal to 30 degrees Celsius. So now, they gave us small c, specific capacity to be 140 joule per kilogram. So from there, we can solve our problem. So H now, for the general formula, what is H saying? H say mc delta theta. Delta theta talk about change in temperature. So therefore, our quantity of heat, H, is equal to mass. Your mass is 50 times C. What is your C? Your C is 140 times change temperature. Change temperature is what? 30 degrees. So from there, you do your calculation, which is H now is equal to, now we can times it little by little. Of course, 30 times 50 put 0 here, 0, 0. Then I put the 30, add 0 from 5, add times it by 5, you have 0, 0, 15. So I have 1,500. So with this and this, we have 1,000, then times 140. We do that again, we have H is equal to 15. I put the 0 on it. The 150, so I add the 0, then I times it with 14. 4 times 0, 0, 0, 0. 4 times 5, 20, carry 2. 4 times 1, 4 plus 2, I have 6. Then 1 times 0 is 0. 1 times 0, 0. 1 times 0, 0. 1 times 5, 5. 1 times 1 is 1. Then you add up. So we have 0, 0, 0, 0, 11, 2 joules. So your answer becomes that the quantity of heat is 210,000 joules. So of course, you want to make it kilojoules, you divide by 1,000, which is the same thing as 201 kilojoules. This 30 will go become 210 kilojoules. So that is our answer. So I'll just take another second example. Example 2. Example 2. Calculate the thermal capacity. Calculate the thermal capacity of a body initially at 20 degrees Celsius, but rises to 80 degrees Celsius after heating. Assuming that assuming that the specific heat capacity of the body is 150 joule per kilogram. Take the mass of the body, so the 10 kg. Because it calculate the thermal capacity of a body initially at 20 degrees Celsius, but rises to 80 degrees after heating. Assuming the specific capacity of the body is 150 joule per kilogram, take mass of the body to be 10 kg. Now, we have two formula I gave us initially. The first one was H equal to MC, delta theta. Second one is what? Capital C equal to N small c. Remember I said that the capital C is called heat capacity, which is also called thermal capacity. Please take note. Heat capacity, note. Heat capacity is the same as thermal capacity. So what the question is saying is that you should calculate the thermal capacity, which is heat capacity, and this is the formula of heat capacity, which is capital C equal to N small c. So we are looking for capital C this time around, which is capital C is your question mark. Your M is given to you as 10 kg, and your C is given to it as 150 joule per kilogram. Of course, they gave you temperature change. You don't need it. So you can be deceived. If you go and use it, you will fail it. Because there's no connection between heat capacity and specific capacity under the use of temperature. So we are not going to use the temperature. We'll just use the formula direct, which is capital C equal to small m C. And your capital C now will go equal to, what's your small m? Your m is 10, and your small c is what? 150. So at the end of the day, you have capital C equal to 1500. So that's the answer. So I will give both some questions, solve it, and send it to me. Let me look at what you have done. You have to answer these questions. So as a way of testing your ability in the subject matter, heat transfer. So number one question says, define the following: A, heat; B, temperature; C, heat capacity or thermal capacity; D, specific heat capacity. Number two question, calculate the heat capacity. Calculate the heat capacity. Calculate the heat capacity of a body of mass 20 kg if the specific heat capacity of the body is 110 joule per kilogram. Number three question, state the factors that the quantity of heat absorbed by a body depend on. Number four, calculate the quantity of heat absorbed by a body whose temperature change is 80 degrees Celsius and thermal capacity being 120 per kilogram or per Kelvin. So now you can send your answers to the WhatsApp number 070 39 688 246. For any further questions, call Mr. Andrew E. on this number 081 41 360 167. Goodbye. God bless you.